Hi everyone, here I am going to discuss about the haloalkanes and haloarenes on the basis of the number of halogen atoms. In my last video, I have discussed about the classification of haloalkanes and haloarenes on the basis of the hybridization of the carbon that is directly attached to the halogen group. So I have taken two halogen compound here. See, this halogen is attached to the carbon. This halogen is also attached to this carbon. But the difference between this and this is that this carbon is sp3 hybridized and this carbon is sp2 hybridized. In order to identify which one is sp2 or sp3, that is, the carbon with single bonded are always sp3, carbon with double bonded are always sp2. So this is called your allylic halide and this is called your vinylic. This is called your allylic halide because this halogen is attached to single bonded sp3 and allylic means 3 carbons with double bond. Okay, so vinylic means it is attached to the halogen is attached to double bonded carbon, and vinyl means 2 carbons only, double bonded 2 carbon. Okay, so now we are going to discuss about again classification of haloalkanes and haloarenes on the basis of the number of halogen atoms. Okay, so here how many halogens are here? Only one halogen, so one means monohalo. Okay, so this is we will mention as alkane, monohaloalkane. Okay, so 2 halogen, so it is called dihaloalkanes. 3 halogen, so it is called trihaloalkanes. Okay, so in same case, similar way, see, 1, so monohalo, there is not alkane, this is ring form, so it is called arene. So how many halogens are here? 2, so it is called dihalo, and this is ring, so it is called arene. So trihalo, 3, okay, 3 halogens, so it is trihaloarenes. Okay, now we will learn about the nomenclature of the haloalkanes and haloarenes. So nomenclature, when we say, we have IUPAC naming as well as we have common name. When we go for the common name, we will always follow this rule. We will always start with alkyl, followed by halide group. First we have to know what is alkyl. So alkyl means it is represented by the symbol, okay, R, okay, bond R, alkyl. So in order to know this is the general formula. All alkyls are represented by R. So in order to know what is alkyl, first we have to know what is alkane. Okay, alkane means, see, the parent name. Okay, so the CH4, this is an alkane. So alkane have the general formula CnH2n plus 2. Okay, where n is the number of carbon atom. So CH4 is an alkane, so only one carbon, so it is called methane. So remove one hydrogen from here, so it change into, not methane, it change into methyl. So this is your ethane. Okay, now remove one hydrogen from this ethane, so it become as C2H5. So this is your ethyl. So methyl, ethyl, propyl are all alkyl group. Okay, alkyl groups. Now let us try to name the common name, as we have learned common name, CH3Br. So when we go for common name, always we have to start with the alkyl. So this is your alkyl. So what is the name of this alkyl? Only one carbon, so this is called your common name. This is called your only one carbon, so it is called methyl. Okay, methyl. Then followed by halide. So this halide is your bromide. Okay, when we go for, let us also learn for the IUPAC name. When we go for IUPAC name, halogen come first always. Halogen is in the prefix. So we will always write halo groups in the prefix, that means in the front, then followed by your alkane. So we will always start with the halogen. So this is bromo. What is this? Bromo. Then alkane. How many carbons are here? Only one, so methane. So bromomethane for IUPAC. Okay, so next let us go for another compound here. So how many carbons are here? 1, 2, 3. If it is 3, what is the alkane and what is the name of the word root? And 3 means propane. So in case of common name, we will always start with alkyl. So since this is propane, we will say as propyl. So this is your bromide, propyl bromide, alkyl halide, so propyl bromide. Okay, so common name alkyl, then followed by halide. So your parent, your carbon chain is 3, so it is propyl bromide. IUPAC name always start with the halogen group. So this is bromo, then followed by alkane, 1 2 3, propane. Okay, let us go to the next one, next compound. Okay, let us go to the next compound. So here CH3, CH3. Okay, so what will be the common name? So there are 3 carbons, so you will write propyl chloride. Okay, so propyl chloride, but we have to write in the proper way. So whenever you see this CH3, whenever you see CH3 bond CH3, when 2 terminal CH are there, 2 terminal CH3, 2 terminal means ending CH3, then CH. Whenever you see this, group, okay, whenever you see this group, remember that we can mention as iso. Okay, we can mention as iso. Okay, so this is also iso, same, both are same, so iso. So we will always mention as iso whenever we see CH3, CH3. This is written in this form, you can write in the straight form also. So iso. What is, after writing iso, how many carbons we have to count? 1 2 3. We have to count the number of carbons also. So iso propyl. Okay, propyl, 3 carbons of propyl chloride. Let's go for IUPAC. Now for IUPAC we have to follow the rules, that is the longest continuous carbon chain. So what is the longest one? Let's start from one end. 1 2 3, only 3. Now we will always number it. Okay, this Cl is in the second position, so it is second, so it is 2 chloro. Okay, 2 chloro, so number of carbon chain is 3, so it is propane. Okay, so in this way, see, I have taken another compound here, this compound. Let us go for naming the common name. So as we have learned earlier, for common name, whenever we see CH3, CH3, 2 terminal CH3 with CH, okay, whenever we see this group, it should be always mentioned as iso. So it is what iso is there. Now count the total carbon, 1 2 3 4. Okay, so 4 means butyl, then remaining chloride. So whenever you see this value CH3, CH3, it is iso. Then count the total number of carbon, the remaining carbon also, that is called butyl chloride. Let's go for IUPAC. When we go for IUPAC, we have to number it, right? The longest, we have to always select the longest continuous carbon chain. So I have written here in this form. So longest is this one. If I count 1 2 3, so this is your longest chain, right? So after selecting the longest chain, this has left out. Okay, so these are taken as substituent. Halogen groups are also taken as substituent. Okay, and we know that this is also taken as substituent. Alkyl group are always taken as substituent. So the substituent are always written in the prefix. So in which position? Numbering. So 1. So as this is functional group, so we will start from here 1. Okay, because substituent or substituent should get the lowest number. So 1 2 3. So in the one position it is chloro, 1 chloro. In the second position it is your methyl, so it is 2 methyl. Total carbon chain of your carbon chain is 1 2 3. So 3 is propane. So this is out of the chain. So this only the chain we have to count. Okay, propane. Now, okay, this we have done. Now let's talk about we will talk about secondary. Now we will talk about, we have learned about iso. Now we will talk about secondary. Okay, we'll talk about secondary, or we can call as sec. Okay, so see, in case of secondary, always we will connect with the second carbon. We will just remove the second carbon hydrogen. Okay, so let us say, see, I have taken the CH3, CH, 2CH, 2CH3, right? So I will just remove the second carbon, I have to just remove the second hydrogen and replace by anything here, either Cl, Br or anything. Okay, so this is called your secondary. Okay, so we have also learned about iso. Whenever I say iso, there is some difference between iso and secondary. So in case of iso, it is also CH. Okay, it is also CH3CH, but in case of iso it should be CH3. It should be, there should be always CH3CH, CH3. But here in this case, it is also, it is secondary. This is also in the second, okay. But in the case of secondary, it should be, see, it is not CH3, it is extended, okay. And this part CH3 CH, if there would be CH3, that it could become as iso, but now it is not CH3, so this is called your secondary or sec, okay. So how to mention the, okay, let's go for IUPAC, okay, let's go for IUPAC. So when we go for IUPAC, we will count it 1. This is our longest chain. We have no other chain. We have longest this chain. So let us number it 1, 2, 3, 4, 5. So you will write as 2 chloro CH L or a chloro. Then 5 means pentane, right? So it is pentane. Now let us go for a common name. In case of common name, we are going to use secondary. Okay, how many carbons are there? 1, 2, 3, 4, 5. Secondary pentyl bromide. This is what? Chloride, CHLORIDE. Okay, so always have a clear idea about iso, secondary. Okay, now we are going to talk about the tertiary. Okay, we have not talked about tertiary. Let us talk about tertiary now. Okay, see, secondary we have talked, we have discussed. Now we'll talk about tertiary or tert. Okay, so when we talk about tertiary, your carbon should be connected. See, your carbon should be connected to 3CH3 group. 3CH3 group. So this is your tertiary. Okay, let's write for the common name first. Okay, common name. So tertiary, so we will use always alkyl. So tertiary, then count 1, 2, 3, 4. Okay, in case of common name, we don't require for serial wise or numbering and all. Okay, so how many carbons are there? 1, 2, 3, 4. 4 means what? It is but. So butyl, TYL, butyl. What is this? Chloride, CHLORIDE, chloride. Okay, so in case of tertiary, in order to know what is tertiary, the carbon should be connected to 3CH group. That is called tertiary. Next, let us go to the IUPAC name or IUPAC nomenclature. We have to go for numbering now. So selecting of the longest carbon chain, this will be your longest carbon chain. If I count from here 1, 2, it will end with 2. But if I count from 1 and 1, 2, 3, then goes for numbering 2, 3, right? So 1, 2, 3. We have 3 carbon chain, the longest one in this compound. Now, in which position is your chloro? In the second position. So it is 2 chloro. We will write 2 chloro, 2 methyl. Okay, 2 chloro, 2 methyl propane. 2 chloro, 2 methyl propane. Okay, so 1, 2, 3. So it is propane. Okay, so we have known about tertiary. Then let's talk about the neo. When I say neo, when I say tertiary, the carbon should be connected to 3 carbon, CH3 carbon. In the case of neo, we have to remember this one first. CH3, 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 CH3. Okay, so remember this one first. Then just remove this one of the hydrogen. Just remove one of the hydrogen from this carbon, any terminal carbon. Okay, so we have removed it and it become a CH2. Okay, then bond. So this part is called your neo. Okay, this is called your neo. So this part is called your neo. Whenever we see CH3 connected to 3CH3, it seems to be okay. Now it changed into CH2. So all is surrounded by the carbon. Okay, carbon, then comes Cl. So this is called neo. This is called your neo. Okay, how many carbons? 1, 2, 3, 4, 5. So it is called neopentyl chloride. Neopentyl chlorides. Okay, here in case of benzene halide or in case of haloarenes, both IUPAC and common names are almost same. See, here we will use as same here, bromo benzene. So this also bromo benzene. Both are same here in this case. Common name and IUPAC are same names are same. Now in case of IUPAC name, here it is little bit different. Now we have two BR group. Sorry, we have two BR group. So in the case of IUPAC name, we will always number it 1, 2. Okay, so this is called your 1, 2. Okay, how many bromo groups are there? So dibromobenzene. Okay, in case of common name, we are not going to use 1, 2. We are going to use as ortho. Okay, so always I'll write here. See, so this BR and this also BR. So this with respect to this is in the second position, right? So it is in the 1, 2 position with respect to this. So this is in the 1, 2 position. We will call it as ortho. We will call this position is called your ortho. Okay, so I will take another compound here again, BR and another BR here. So this in which position? This 1, 2, 3. So 1, 3 positions are called always meta. This meta, and it is in the 1/4 position. If it is in the 1/4 position, so BR with respect to this 1, 2, 3, 4 in the 4th position. So this is called your so BR in the 4th position, this is called your para. Okay, so para position. So we will use ortho as O, meta as M, and para as P. Okay, so with respect to this in the 2nd position, so it is called ortho. With respect to this is called in the 4th position, so it's called bromo. It's called 4th position, it's called para. Okay, in the 3rd position, so it is called 1, 2, 3, 1, 3 position, so meta. Here let us mention here, this is in the for IUPAC name, this is 1, 2. So this is called 1, 2, 1, 2 position. So for IUPAC numbering will be there 1, 2. How many bromine groups are there? 2. So it is called dibromobenzene. But in case of common name, we are not going to use number. We are going to mention in the form of ortho. So with respect to this in the ortho position, 2 position means ortho. So we are going to use ortho as symbol O dibromobenzene. Okay. So in this way, this in the 1 with respect to this is in the 4th position. So 1/4 is called as, this is for the common name. So para, 4th position, which so para dibromobenzene. Okay, and for IUPAC name, see, it is 1/4. We will always number it 1,4 dibromobenzene.